Good morning, everyone. Today we're going to be doing experiment number 19, which is sort of an extension of experiment number 2 we did earlier in the semester because it once again deals with solutions. But this time we're going to go into much greater depth. You're going to be making solutions of 4 different compounds. We have sodium chloride, sodium acetate, ethylene glycol, and acetic acid. And we're going to be making 4 solutions of each of those, a 5%, 10%, 15%, and 20% solution. So that's a total of 16 different solutions that we'll be making. Normally, when we do this experiment in person, we would get groups of 4 students, and each of you would make 4 of the 16 solutions. Of course, I'm here by myself today, social distancing, so I'll be making all 16 of those solutions. Now, when you do the experiment online, your instructor may have you split up the work, the calculations, so that each of you is doing only 4 of those, or they may have you do all of them yourselves. That'll be up to myself or whichever instructor you happen to have when you're taking Chemistry 3A. So Part A we can skip for the moment. That's simply making our teams. Part B is the preparation of the solutions. So we're going to be making those 16 solutions. The easiest way to make them is to make a total of 100 grams approximately of each solution. So we could, for example, take 5 grams of sodium chloride, place that in a beaker, add 95 grams of water, we have a 5% solution. Our second one would be 10 grams of sodium chloride and 90 grams of water, and then 15 and 85, and finally 20 and 80. So that will give us approximately a 5, 10, 15, and 20% solution of the sodium chloride. We'll repeat that then for the other 3 compounds. You don't have to worry about getting it exact. It should be relatively close, but whatever the concentration is, you're going to measure it specifically anyway. So we're going to determine it based on the masses you record precisely. If it's 5.1% or 4.8%, that's okay as long as we know what it is. Once you've calculated those weight percents, we're going to measure the densities of each solution and then use that to calculate the molarity. And finally, one of the questions we'd like to ask in the lab, and we talked about this a bit back in experiment 2, is are the volumes of solutions additive? When you mix 2 solutions together, can you simply add their properties? So you're going to be doing some calculations to determine what the density of each of these solutions ought to be, and you can compare that to the densities you actually measure in the lab, and then you'll be preparing a graph with this information at the end of the lab. So that's basically what we're going to be doing today. I'm going to head over to the lab here in a moment and start making those 16 solutions. At the end of that time, I will have a little post-lab video, and I'll take you through an example of one of these calculations. So I'll take one of the 16 trials and show you how to do the calculations, then you can go ahead and carry out the rest of them. So let's head on over to the lab and get to work. All right, let's begin with the sodium chloride. So first we need to weigh our beaker and record that mass. Now to make this easier, I'm simply going to tare the balance, and that way we can measure our mass directly. So for this first solution, we want a 5% solution, so we're going to want about 5 grams of salt. So we'll try to get as close to that as we can. I think we'll be able to do a pretty good job here. Yes, I am a rather meticulous person. So it looks like we got very close to 5 grams. Now, to make things a little simpler, rather than measuring out the water in a separate container, I'm simply going to add the water to the beaker. We want a total of 100 grams, which means we need about 95 grams of water. So let's start adding the water to that until we get to 100. We're very close now. Let's use our squirt bottle to try to get a little more accurate here. That's pretty darn close. And that looks pretty good. We get almost 100 on the nose, so make sure you record that mass as well. And then we'll go ahead and stir that solution, get it dissolved, and then we'll measure its mass and volume. Now let's go ahead and do our 10% sodium chloride solution. So we'll weigh our empty beaker and go ahead and record that, and then I'm going to tare it once again to make things simple. And this time we'll want about 10 grams of salt. I'm getting pretty close there. That looks very close. And now we'll want to add enough water to once again have a total of 100 grams. And now we'll use our dropper bottle to finish up here. But a little bit over, but it's pretty darn close to 100 again. So that should be our 10% solution. Now let's do our 15% solution. So we'll get the mass of our beaker. Go ahead and tare that once again. And now this time we want 15 grams. We're getting close again. And it looks like we've just about got 15 on the nose there. So let's add enough water to once again get up to 100. And now we'll use our dropper bottle here. Well, we're just about there. And that looks pretty darn close. So that will be our 15% solution. And let's finish up sodium chloride with our 20% solution. So there's the mass of our empty beaker. Let's go ahead and tare that once again. And this time we'll want 20 grams or so of sodium chloride. All right, we're getting pretty close here. That looks pretty darn good. Well, really good. So there's our 20 grams of sodium chloride. Now let's add our 80 grams of water to that. Alright, and we'll just finish that up with our dropper bottle. And that looks very close. So that should wrap it up for our 4 solutions of sodium chloride. Now let's do our series with sodium acetate. So as usual, we'll get the mass of our empty beaker. And let's go ahead and tare that. And then to make the sodium acetate easier to work with, I poured some into a small beaker. So we want to get 5 grams of this. Oh, we're getting pretty close here. That looks pretty good. That's almost 5 grams. Now we'll add our water to get up to 100. All right, and let's finish that up with our squeeze bottle here. And that looks good. So there's our 5% solution of sodium acetate. Now let's do the 10% solution of sodium acetate. So there's the mass of our beaker. We'll tare that, and now we want to add 10 grams this time, or approximately that much. And that looks perfect, just about right on the nose. Now let's add our water to get it up to a total of 100. And we'll finish it off with our squeeze bottle. And that looks great. Just about exactly 100. Now let's do the 15% solution of sodium acetate. There's our beaker mass. Let's tare that. And now we'll want to add 15 grams this time. We're getting close. There we go. Very close. And now we'll add enough water to get up to 100. And switch to the squeeze bottle here. Just about there. And that looks good. And let's wrap this up with our 20% solution of sodium acetate. So record the beaker's mass, and we'll go ahead and tare that. So this time we want about 20 grams. Just about there. And let's see, just a teeny bit more. All right, that's just about it. And now we'll add enough water to get to 100. And we'll sneak up on it here. Just about there. There we go. Perfect. So that's our 20% solution. Next, we'll prepare our solutions of ethylene glycol, commonly known as antifreeze. So let's go ahead and get the mass of our beaker. And we'll tare that. And I think for a small amount here, let's just use a dropper to get our 5 grams. That should go pretty quickly. All right. See if we can sneak up on it here. That looks pretty good. Now let's go ahead and add some water to get it up to 100 grams. All right, let's use our squeeze bottle to finish it up here. And that looks great. So there's our 5% solution of ethylene glycol. Now let's do our 10% solution. So there's the mass of our beaker. Tare that back to 0, and this time we want 10 grams. Well, that shouldn't take too long. And we're just about there. Perfect. Right on the nose. Now let's go ahead and add enough water to get to 100. Let's go ahead and finish that off here. And that looks just about perfect. Now we'll do our 15% solution. So record the mass of the beaker. Go ahead and tare that. So this time we'll want 15 grams. That's probably about 6 droppers full. And that's about half of it. There's 5 droppers, and we're just about there. Very close. And that looks great. Let's go ahead and add our water to get to 100. think that will be good. That's very close. And now let's make our 20% solution. There's the mass of our beaker. Let's tare that. And we'll need a bit more this time. So we want to get 20 grams approximately. That'll be about 8 droppers full. All right, that's about the halfway point. And we're just about there. That looks just perfect. And now we'll add the water to get it up to 100. Just about there. And that is just about right where we want it to be. So that wraps up the ethylene glycol samples. Our last set of solutions will be acetic acid. Now acetic acid is what's in vinegar. Vinegar is about a 5% solution. This is pure acetic acid. It's much more concentrated, so that's why I'm going to wear a glove here just to be careful. So let's go ahead and get our beaker weighed, and we'll tare that. And now we'll want 5 grams of our acetic acid. Ooh, smells like vinegar. All right, we're just about there. That looks good. So we'll go ahead and add enough water to reach 100. And that looks very close. So that's our 5% solution of acetic acid. Now let's do our 10% solution. There's our mass and our tare. So this time we'll want about 10 grams. We almost had enough there. Just a little bit more. That looks fine. All right. Let's go ahead and add our water. looks good. Now for our 15% solution. There we go. Let's tare that. And this time we'll want to have about 15 grams. Looks like that'll take about 6 droppers or so. And this last one ought to do it. That looks pretty close. Now let's go ahead and add our water. And that looks great. And finally, our last solution will be the 20% acetic acid. There's our beaker's mass. And this time we want about 20 grams, so that's probably going to be about 8 droppers full. Now there's 4, and we're a little over halfway. And just about there. That looks lovely. So that wraps up our 16 solutions. Now we need to measure the mass and volume of each of those solutions. But let's not forget, of course, to add our water. We'll need to bring this up to 100. And that looks good. Now we're actually done. That's all 16 solutions. Now we need to measure the mass and volume of each of the 16 solutions. So we'll start out with a clean, dry 100 ml graduated cylinder. And then again, to make things simple, let's just tare that. And now let's add to that our 5% sodium chloride solution. All right, so record that mass, and then we'll go measure the volume. Now we have our 10% sodium chloride solution. There's our graduated cylinder's mass. Now let's go ahead and add that. And if you look at these carefully, you'll notice that the mass is just about the same each time, but the volume is dropping because of the increased density. This is our 15% sodium chloride solution. All right, there's our mass. Now let's see what the volume looks like this time. Definitely less. And this is our 20% sodium chloride solution. All right, let's get that taired. And that volume's significantly lower. Now we'll take a look at our sodium acetate solution. So this is the 5%. Okay. There we go. So record that mass. This is our 10% sodium acetate solution. There we go. Again, the volume looks like it's decreased a bit. And here's our 15% sodium acetate solution. All right, let's go ahead and add that. There we go. Looks like a similar mass to the last one, but the volume definitely dropping. And now our 20% sodium acetate. And that wraps up the sodium acetate series. And now we'll begin our ethylene glycol group. Get that taired there. So this is the 5% ethylene glycol. This is our 10% ethylene glycol. This is our 15% ethylene glycol. You might be noticing something interesting here. Now that we're using two liquids, the volumes are staying pretty consistent across each sample. This is our 20% ethylene glycol sample. And again, it looks like the volumes were fairly consistent across all four samples. So let's finish things up with our acetic acid sample. Again, I'm going to use gloves, even though it's been diluted quite a bit now. But just be careful. So this is our 5% solution, which is basically vinegar. This is our 10% solution of acetic acid. This will be our 15% acetic acid solution. And finally, this will be our 20% acetic acid solution. And interesting, as we saw with the ethylene glycol, there was not a huge difference in the volumes when we mixed liquids with the water. Now let's go ahead and measure the volumes of each of our 16 samples. So this will be our 5% sodium chloride solution. Next, we have our 10% sodium chloride solution. This is our 15% sodium chloride solution. And this is the 20% sodium chloride solution. Now let's move on to the sodium acetate solutions. This is the 5% solution. And this is the 10% sodium acetate solution. This is the 15% solution. And 20%. Now let's take a look at the ethylene glycol solutions. This is the 5% solution. And this is the 10% solution. This is the 15% solution. And finally, 20%. Our last series will be acetic acid, and this is the 5% solution. And this is the 10% solution. Next up, we have the 15% solution. And finally, our last sample will be the 20% solution of acetic acid. Let's wrap up today's lab by running through a sample calculation for one of the 16 solutions that we tested, and then you can go ahead and do the other 15. So let's take a look at the 15% sodium chloride solution just as an example. The first thing that we're asked to figure out is what the mass percent of salt is in the solution. So that means we need to know how many grams of sodium chloride we had and what the mass of the total solution was. And if you look through the videos, you will find that we measured both of those things at the beginning. We had 14.98 grams of salt, and once we added the water, we ended up with a total mass of 99.92 grams, and that gives us a mass percent of 14.99%. So we came out very close to that goal of a 15% solution. The next thing you're asked to determine is the density of your solution, and of course, as you I'm sure well know, density is simply mass over volume. So we need to know the number of grams of the total solution, and we need to know the volume of the solution. So we measured both of those later on in the lab in our graduated cylinder. In this particular case, we found that there were 98.98 grams of solution in our graduated cylinder, and the volume was 90 milliliters, and that gave us a density of 1.1 grams per milliliter. The third thing we want to figure out is the molarity of the solution, so we need the moles of solute and the liters of solution. As a starting point, we know how many grams of sodium chloride we started with, and we know how many grams of solution. We measured both of those at the very beginning in the beaker. So we simply need to get the grams converted to moles on the top and the grams converted to liters on the bottom. First, we can change our grams of sodium chloride into moles using the molar mass. Then, using the density of the solution, we can convert the grams of solution into milliliters. And finally, we need to change milliliters into liters so that we end up with units of moles per liter, or molarity. And then the last thing that we wanted to figure out was the theoretical density. We could calculate what the density of this mixture ought to be, and that's assuming that the volumes of both substances are perfectly additive. And that's one of the things you're trying to determine today. If the volumes are exactly additive, then your theoretical density should be the same as the density you measured. Of course, to get the density, as always, we need the mass over the volume. The total mass means the mass of the salt and the water, and the volume is the volume of the salt and the water. The masses are easy because we measured those two things directly in the lab. Volume is not so simple. You can't really measure the volume of a granular material like sodium chloride because there's lots of spaces in between the particles. So we're going to go at it a little bit indirectly. We're going to calculate the volume of our salt by using the mass and the density. If we rearrange our density equation, we can solve for volume. We know that we had 14.98 grams of salt to start with, and we can look up the density of salt, and we can use that to calculate what the actual volume of sodium chloride is in that sample that we measured out. We can do the same thing with the water because we didn't actually measure the volume of the water initially, but we did measure the mass. As you recall, we measured the mass of the water and the salt together, and we also measured the salt separately, so I simply got this number by subtracting those two. And the density of water at room temperature is 0.9978 grams per milliliter, and that gives us the volume of water. So we can simply add these two together, and that will give us the volume. The mass of the solution we measured at the very beginning, and so we simply divide those two, and we come out with our theoretical density. It turns out that our theoretical density was actually very close to our measured density of 1.1 grams per milliliter. So you're going to go ahead and calculate this for the other 15 solutions, and then you can use that information to prepare the graph at the end of the lab and to finish filling in all the tables of data for the other 15 solutions.